Cool. Thank you, everyone, for being here, and thank you for making it an amazing KubeCon. So before we jump into the topic, there's something really short I want to jump into. And first, this really is about the community. Everything you see here, like everyone that is working on all these projects, it's at the bottom we have people that are here. So like first, round of applause for everyone who is here, who is part of the community, and for everyone who is not here, who is unable to attend. And one other thing as well is that you'll see a photo of this. I'll actually make a point of this pretty soon. But if you are also in need of, like, if you're feeling burnt out, if you need help, like, please reach out to somebody. Please look after yourself. Like, this is not a sprint. It's a marathon, and it's something that we want to make sure everyone is doing things they can, not only for the best of the projects, but also for the best of yourselves. So make sure that you are also looking after yourself. Drink lots of water, get lots of sleep. Make sure that you're enjoying yourself and help make it a safe space, not only for yourself, but for others. So again, thank you. So let's jump into it. There's this concept that we have called Emergent, and so Emergent system. So it's when you have a system where the individual components that make up the system do not actually have the properties of the system as a whole. They have unique behaviors that arise as part of that system. The first example is you have this ant. So you have a flood that comes along, the ants all cluster together, and now they float. And last I checked, ants don't tend to float very well and survive. But in this scenario, they gather together. You also have all of the pheromones that they put out. So like the individual, like how do they go off and gather and act as a whole? Like they have entire behaviors that are not actually encoded into the ants. But when they get together, they actually have a set of behaviors that they act like in unison. Also, I mentioned about self-care. Remember, there's some ants at the bottom of these things that are actually latching onto the grass. And so if you're feeling burnt out, you're probably one of those ants. Pop up for air and ask for help and ask for somebody to help you with that task. So you also have another famous example, which are the cathedrals that you see here, where you end up with a bunch of termites coming together and they build up these really amazing structure. But specifically, there's a few properties that an emergent system has, which is there's no global control. There's not a single entity in the center that's like guiding everything and saying, you're gonna do this, and you're gonna do this, and you're gonna do this, and like mapping everything out. There's also, you couldn't even do it anyway because there's no global observability. You don't have the ability to see everything. There are things going on in projects. Like I got a lot of visibility compared to many others. And I can tell you, I can only see the tip of the iceberg. I cannot see everything that is going on. And so since there is no global observability, yet despite that, we still have a convergence. Where that convergence occurs, there's a given structure that arises out of it. And so the system that has that structure behavior is not present in the individual components, and yet we still have this amazing, beautiful thing that comes up. There's also an emergent structure. So those are emergent behaviors, but you also have emergent structures where things get put together and welded. And so in this scenario, you have these ice crystals that have formed. And if you look at how water ends up working and how they all combine, like you can have these type of structures arise. And I also put this as a previous KubeCon, I believe it was 2019 Europe and I want to say Barcelona. But in this scenario, we have a whole economy of people. Like you are in here, you're part of an economy, you're part of a organization of people who every group is acting in different ways, and yet we still have all of these amazing things that come out that, as Priyanka described before, affect 7 million other people that people are depending upon. And this is one of the central places where you can come together and be a part of that story and help influence the direction. Again, not control, but to influence. And so, how do we influence then? We start with open standards. So, open standards drive commoditization. And we want to make sure we have the definition here. So, when we say commoditization, we don't mean commodification. So, commodification is where you're taking something that was like not sellable and you make it sellable. In terms of commoditization, what we're looking at from this definition is something that anyone can use, that it's easy to access, that you can just pick up and start using. And so we want to focus specifically on open standards and specifically on the word open. So I know there's a lot of definitions that people tend to have. I tend to use the OSI definition of open in terms of open source. It's something that is accessible to everyone, something that is approachable, that, like if I go and decide, hey, I want to go and use HTTP, there's no one there saying, no, you can't use HTTP because it's a closed standard. And this is super important because without, these open standards are what drive the ability for people to consume, but it also represents a place where we can influence. And so as we move forward, that open standards ends up enabling emergence. Like we have IP and how much stuff is built on top of IP. We have HTTP, how much stuff is built on top of HTTP. In cloud native community, we have things like the Kube API. How does the Kube API end up affecting your ability to deploy or to build products on top of? So with open standards, like part of what we should be looking at is how can we make sure that we're putting into the properties that we're influencing the structure and then making the structure predictable on what the outcomes are likely to be, knowing that we're not going to control everything. It's that we shouldn't even try to control everything, but we should try to put things in a way that are flexible enough so that people can go and do interesting things, but we all converge back to a central location. So in this scenario, we're saying cloud native embraces open standards. And if you want to know what it means to be cloud native, I know we have the official term cloud native and all the talking about like tight loops and feedback loops and similar. But I would also argue that if the standards were not open, if people were not free to come and use it, we would not be here. We'd be having a very small trade show at the most if we were lucky. So the reason why we are so successful is because we have been working on building new, and even though they're not technically standards by the official definition, like there's no board there in some of them, and actually some of them do have boards now, but generally you start off with like, well, let's go and find something we can work on that we can all come together and put a stake in the ground and say, this is where we're gonna start. It doesn't mean it gets ossified, but it's something that in time we can continue to build and rally around. So that means that if we're embracing open standards and we're thinking about how do we set things up so that everyone can access, so we get that diversity of people, diversity of ideas, at that point, we are embracing the concept of emergence, embracing the concept that we can actually come together, we don't have to control everything. So, like I mentioned, we are building standards. Like if you look at every single one of these things, even if you don't technically call it standards, like there are protocols, like you have a Kubernetes API that says like, how can I go and deploy things? I have like the OCI that describes a variety of different things on how do I actually run an image or how do I package a container image. Things like CNI that control networking, gRPC. So like you have all of these different things that people are rallying around. And they're all also opportunities that if they're not going to be perfect. So part of it is these are some of the plays, not the only ones. This is a very small list of everything that we're doing, but part of the challenge is learning what's out there so that you can then learn not only just what you're doing, but you can learn from others who you're working with, and you can tie it back into what you're doing for those standards. And a really good example that I like to use in a scenario is with, like I do a lot of work with Spiffy, and Spiffy represents a path for how do we get identity where I set up my Spiffy identities for my workloads and another company might set up theirs. It gives the opportunity that I can consume their identities and I don't have to know anything about their internal infrastructure. We have something on the top. In the same way that I don't have to know anything about your infrastructure if I'm using HTTP, I can do a GET call on it and it'll act in the way it's supposed to, which might be giving me something, or maybe it tells me you're not authorized, but I'm gonna get something that's predictable. So with things like Spiffy, I'm able to get that identity across boundaries, and I can start reasoning about other entities, and that has massive implications. There's another thing to consider as well. It's not just about the technology. Like I said, it's about the people. And how many people here used to run infrastructure before you adopted Kubernetes? Like you're the person who has to run you're like the person who's part of the run book, and they say, okay, John, it's your turn to go and set up the script. John, Amy, it's your turn to go and set up the firewall. And something goes wrong. And so you have these really complex systems. And again, thank you for Duffy for having this conversation with me, because this has helped me set this up. And so part of what we have to look at is what are the human processes that we have? What are we changing? So everything that we put on our APIs has an implication on what happens in terms of our human processes, both positive and negative, because like I mentioned, a lot of people have burnt themselves out trying to manage these systems because there's not enough of us here. But at the same time, it also provides a path towards, like, I can build an image and I can give you an image, and if you want to run it, there's nothing special you have to do in order to understand how my image works, at least from the infrastructure side. Like, sure, from the application side, you have to learn something about how my image works, but that doesn't say anything about, I don't have to give you very much information, because it's all in the specs, it's all in the standards, and we continue to improve on those so that everyone gains those capabilities. So many of these processes have been standardized through the Kubernetes API. So please, like, whenever you're thinking about standards, or you're thinking about, like, how do I build the protocol out, always think of the people. Think about how people are going to consume it. How is this going to affect the people who are going to be up late at night deploying your code out? I want to also make a prediction as well. So today, now that we've covered emergence and how the entire space is an emergent system and we're an emergent community, we can also think about where are we going next. And so if we take this as initial standard, one of the patterns that I'm seeing is we have a really clear definition on what an application is, and that continues to become more generic. And Kubernetes is an orchestrator. It is definitely one of the most popular ones. It is becoming commoditized. We have turnkey solutions for it. But at the same time, the applications themselves, they have different places where you may want to run. So there are teams over here who I've been working with who have been working on 5G edge computing. And they're trying to work out, how do I deploy my application so that actually lives close to you? Like, maybe you're working in manufacturing and you're trying to control a robot. The latency to your cloud is too much, and so you have something close by. Or self-driving cars are often another example. You want something that's close by so that if you lose the link to your cloud environment, you still have something operational that's close by. So we have these applications that eventually we will start to schedule. We'll have a manifest. We'll have something we can describe. What are the requirements of the application? Then be able to deploy that application anywhere in the world based upon the properties that are there. If you need a GPU, you land you into an environment that has a GPU. If you're a WASM-based system, then we have to make sure we land you into that correct area. And there's numerous places that today you can start to deploy against. So not only with Kubernetes and clouds and edge systems, we're also seeing CDNs actually starting to run workloads in their actual environments that land literally, like, within some scenarios within a kilometer of where you're at, depending on your location. And so we have a whole set of protocols that have been serving us well here in the cloud native. And I believe that we're able, if we are careful as a community and thoughtful with how this works, I believe that we can take it to the next level and set it so that instead of just being bound primarily to Kubernetes, we can actually make this so that it's something that is useful globally, that my infrastructure, things that I'm working on connects into your systems, that we have those top-level APIs, those top-level systems. Of course, an escape hatch, because you sometimes need things that are not provided by those systems. But if we can get most of our environments to think in that specific way with uniform approaches or close to uniform approaches to this, and get down to better standardization, I think we can have something that's much bigger than just Kubernetes and cloud native and just what's within this community. So with that, this is the main point I want to make, is that the standards that we have, they will continue to evolve, and they will allow us to schedule anywhere to have that interaction where we can then predict, like, we can then deploy to anywhere or any particular group based upon the needs of the application, rather than what was the system, what infrastructure was that system designed for. So with that, I want to thank everyone for your time, and have an amazing KubeCon.